IGCSE Physics. Topic name light, the subtopic name lenses. Lenses, two types, convex, concave. Another name, converging lens, diverging lens, convex lens, concave lens. At the edge it is thin, center it is thick. At the edge it is thick, at the center it is thin. What is converging? There are three types of light rays. Light beam, the rays joined together, it forms a beam. There are three types. We have three types of beams. One is parallel beam. So the light rays are parallel. All the light rays are parallel, and the combination of these light rays are called a parallel beam. And next we have diverging beam. The light rays are going away from each other, right? So diverging beam. Then we have the third one, converging beam. All the light rays are meeting at a point. It meets at a point, so it is a converging beam. Here, if the object is very far, for example, sunlight, and here is our earth, when the light rays here produces a diverging beam, as it comes from very far distance, when it is reaching to the earth, it becomes parallel. Because some portion of the light rays are being reached to the earth, so it becomes parallel. So if you see the light rays are parallel, you should imagine the object is very far. So if the light rays are parallel, what do we have to think? The object is very far. Okay. If you see a diverging beam, which means the object is closer. So you have to observe whenever you solve your question paper, check if the incoming light rays are either parallel or it is diverging. If it is parallel, the object is very far. If it is diverging, the object is closer. So it is very important. Okay. Now it is a convex lens. Now I draw the light rays, a parallel light rays. So which means the object is very far. They will not give. Just by observing the light rays, we are deciding the object is very far. It is located very, very far. And now this is a convex lens. Another name is converging lens. So all the parallel light rays are being converged at a certain point, So this point is called focus, symbol capital F. And from the center, optic center, the lens, the center of the lens, optic center to the principal focus, there is some length, there is some distance. This distance is known as focal length. Focal length, and the symbol is simple f. So here the alphabet is very important. Capital F is a principal focus. That means it is a point at which all the light rays are being joined or combined or met, or it meets at a point when the light rays are coming from very far object. It refracts once it is passing through the lens. It refracts at this point. It refracts means what? The bending of light. It bends. The light rays are bending because it is made of glass. The lens is made of glass. So light rays are being refracted and it meets at a point. The meeting point is called the principal focus, and we give the letter capital F. And the length between the principal focus to the optic center is called focal length. Okay, so this is the basic thing. And now another one diagram is there. What if the object is closer? We have to draw a divergent beam because the object is closer now. If the object is closer, you can just observe the divergent beam. If you see in the question paper divergent beam, you should imagine the object is closer. Okay, and then you can see in the other side what is the function of the this convex lens. All the light rays are being joined or combined or met at a point, at a certain point. It will bend the light ray and it will focus at a point, at a certain point. So here, this one I cannot say focus or the principal focus. I cannot say the focus. It is not a focus now. Even though it is joined, all the light rays are joined this point. Now I cannot call this point as a principal focus or a focus because the object is not very far. So if you want to get the principal focus, the main condition, there is a condition, right? So what is the main condition? The object should be very far, very far, and the light rays, the beam must be parallel. The parallel beams, you should see the parallel beam like this, parallel beam. Now here is the divergent beam, so this will not be a focus. So we say it is the image point. The image is created at this point. Here also image is created at this point. As since it is the parallel beam, we call them principal focus. As it is not a parallel beam, we just say it is the image point. And the length between the optic center to the image is called image distance. That is V, image distance. Distance between the object to the optic center is called object distance, U. So the U is known as object distance, and V is image distance. Image distance. Now we have some important tricks. I can give some example here. We have a lens, a thin lens, and we have another lens. It is the thicker lens. Both are convex lens. And take a source, a light source. Now it is closer to the lens, so it must be a diverging light beam. Diverging beam is produced, and same light source and same distance, and this also produces the same. And now here you can see the light rays will be converged far away. Here you can see the light rays will be converged closer to the lens. Here is the image. Here is the image point. So here the image distance V is smaller, and here the image distance is bigger. By using the same light source, we are using the same light source and same distance. We are using the same distance. The object distance is the same, which means the U is the same, but the value of the magnitude of image distance varies. So what do you understand in this? Thin lens refracts the light comparatively lesser than the thick lens. So the thick lens bends the light, refracts the light more because it has more power. It is powerful. It is more power than the thin lens. So here is the thin lens and here is the thick lens. So this point is important. And we have some rules. There are 3 rules that we have to follow when we want to draw the ray diagram. Okay, so what are those? First rule is, when the light rays are passing through the optic center, it will not bend, it will not refract, it will go straight. It will not bend, it will go straight. And don't forget to draw the arrow marks, incoming and outgoing. This is rule number 1. Through optic center, light rays will not bend. And second case, what is the second case? Second rule. Okay, so if the light rays are parallel to the principal axis, this center line, the horizontal center line which is passing through the optic center, is called the principal axis. Now if the light ray is parallel to the principal axis, the light ray will pass through the principal focus of the lens, that is capital F. It will pass through the principal focus, right? So parallel ray passes through principal focus. This is the second rule. And the third rule, first you draw the principal axis, and now the light ray which is from the principal focus, which is coming from the principal focus, will become a parallel light ray, to the principal axis. So ray from principal focus refracts and it becomes parallel to the what? To the principal axis. Okay, so these 3 rules are important to draw the ray diagram. Now we are going to draw the ray diagram. So what is the importance of drawing the ray diagram? Using the convex lens and concave lens, what is the use of those lenses? To create the image. So when we want to create the image, we should know the location of the image and the nature of image. So we need to draw the ray diagram. If you draw the ray diagram, we can find the location of the image and we will know the nature of image. So location location and nature of the image we can find by drawing the ray diagram. In the examination, sometime they will ask, draw three rays to locate the image. To locate the image. Most of the time, just they say, find the image position. Find the image, that is the location. Find the location and nature. After drawing this ray diagram, we will know where is the location of the image and what is the nature of image. Then continuously there are some other questions like find the magnification or image distance, find the image distance, find the object distance. So there are many other questions we have after drawing the ray diagram. So first important thing, to draw the ray diagram. So what is the use of drawing the ray diagram? To locate the image, to find the location of the image and the nature of the image. Okay, so we can start to draw the ray diagram. So I told you three rays to locate the image, or two rays to locate the image. Two rays is enough. Now this first two rules, if you follow the first two rules, you can get the image of an object. But sometime examiner in the examination, they will they specifically they ask, draw the three rays to locate the image. Then we have to draw the three rays. Okay, now ray diagram 1, that is the we have cases like case 1 2 3 4 5 6 cases we have. Sometimes 5 cases they say, 6 cases, so whatever, we can just follow this. Case number 1, what is the case number 1? Now here is a lens and you draw the principal axis, and this is the optic center O. From the optic center O, you can take some length like 2 centimeter or 3 centimeter, 4 centimeter, whatever you like. Just you take to the left side, from the optic center to the left side, and right there principal focus. We are assuming it is like a scaling. And the same, if suppose the distance is 2 centimeter from focus to the other side, will also be 2 centimeter, the same distance, and right there 2f, and follow the same to the right side, f and 2f. So here the distance between OF, F to 2F, the same F to 0 to optic center to the F, and F to 2F are the same distance. Okay, follow the same distance. If the distance are not same, then you cannot find the location exactly. So it is very important. Okay, the first case, I'm going to keep an object beyond 2F. This is beyond 2F. Here is an object, and I draw the arrow mark, which means it is upright object. So this is an object. Now I'm going to follow the rules one by one. What is the first rule? I told the whatever the line which is passing through the optic center, it will not bend. So this is the first rule. It will not bend. And draw the arrow mark. Don't forget to draw the arrow mark. And second rule, if the light rays are parallel, if the light rays are parallel to the principal axis, it will pass through the principal focus. And don't forget to draw the arrow mark. Now you can see at this point the light rays are meeting at this point. So this point, the point of incidence of the two rays, here the image is formed at this point. Here you can see the image. Okay, now two rays, just if you see this, I used only two rules, and then I find the location of the image. I find the location. Where is the location? It is in between F and 2F. It is in between F and 2F, the image is located. And what is the nature? Nature of image? The image is smaller it is called diminished. Diminished means smaller than the object. The size is smaller than the object. And if you observe it clearly, you can see it is inverted image. It's not upright. It is inverted image, upside down, inverted image, right? And the light rays are coincide, means they intersect at a point. So the light rays, if the light rays directly intersect, meet at a point, the image is called real image. Real image. So here there are three. One is smaller than the object, and it is inverted, and it is real image. So three nature. We have three nature of image. We found it. Now, if examiner asks to draw three rays to find the location, what we have to do? The third rule. We have to follow the third rule. That is, when the light rays, now the third rule, we can follow the third rule. Uh, the light rays are from the principal focus. When the light rays are from the principal focus, that means the line is passing through the principal focus, and it will become parallel. It will become parallel to the principal axis. Parallel to the principal axis. Now three lines are meeting at this point. So first two, this is number one, and this is number two. First ray passing through the optic center, second ray parallel light ray passing through the principal focus, and third ray, here is the third ray, which is passing through the principal focus, and the other side it will become the parallel rays to the principal axis. All these three light rays are coinciding at a point, intersecting at a point where the image is formed, and the image is smaller, diminished, inverted, and real. This is the first case. And in the exam, normally they give you the graph and the lens also. So you can draw, if it is difficult to draw the convex lens, you can draw the arrow mark like this, and you can write it is a convex lens, or the convex lens in the exam it is given. In the graph paper, the lens will be given. If the lens is not given, you can draw arrow mark like this and just label it is a convex lens. Okay. Now it will be easier for you now to scale f and 2f. Here you see, here f, and here 2f, same here f, and here 2f. Okay. They will not in the exam, they will not give you like this, place object beyond 2f. They will not give this word, keep object beyond 2f and find the nature of image or the position of image, will not be given. Instead, they give you like this: focal length is 10 centimeter. The focal length of the convex lens is 10 centimeter, and an object place an object at 30 centimeter, will be given like this. And you know that here is the optic center, and the principal focus is f, and this length is the focal length. The other side is the same. This length is the focal length, and it is mentioned as 10 centimeter. So this unit, the scale, is 10 centimeter scale. So it must be 20 centimeter, and this must be 30 centimeter. Here is 30 centimeter, and you are going to place an object at this point. So place an object, and the object length also will be given sometime. The object length is 5 centimeter. So 5 centimeter, just you can count 1, 2, 3, 4, 5. So this length 5 centimeter, or even you can draw the height, any height, and just you label it is 5 centimeter object. Okay. So how many units? 1, 2, 3. 3 units, 5 centimeter. 5 centimeter. Okay. Now we are going to draw the ray diagram. What is the first step? First step, draw the line which is passing through the optic center, and don't forget to draw the arrow mark. And second case, the parallel beam to the principal axis, and which is passing through, it should pass through the principal focus, and draw the arrow mark. And then third case, the light ray should pass through the incoming ray through the principal focus, and the other side it will be parallel to the principal axis. Parallel to the principal axis. All the three light rays are intersecting at a point. So this point is the image point. The image is formed. Here is the image. Right? So here you know the location of the image. Where it is located. Image is located between F and 2F. And what is the nature of the image? It is diminished, means smaller. Image is smaller, diminished, and it is inverted and real. Okay, now I want to find the magnification. There is a formula, that is V over U, or image over object, I divided by O. What is V over U? V is the image distance. So this distance is the image distance, V. What is U? Object distance. So this distance is the object distance. That is U. So what you can do, you can follow the scale. That is, here the scale is 30 centimeter scale, 30 centimeter, and here from 0 to F 10 centimeter, and here to here 20 centimeter. As it is located in between, it must be 15 centimeter. The image length is 15 centimeter. You can do in this way. There is one more way. What is one more way? Another way, you measure this length using the ruler. This length, for example, this length may be 10 centimeter. Example, this length may be 10 centimeter, and measure this using the ruler. This may be 5 centimeter. Okay, now I want to find the magnification. Image distance divided by object distance. Image distance is 5 centimeter. Object distance is 10 centimeter. So my magnification value will be 0.5, no unit, because centimeter is cancelled, no unit. Now this value, just you observe this value, it is decimal value, means smaller than 1. If it is smaller than 1, the size of image is diminished, means smaller than the object. If the magnification value is 1, then we should know the image and object size are the same. If the magnification value is more than 1, example 1.5 to 2.53, you should know the image size of image is bigger, magnified, bigger than the object. Okay, so what is the formula? V divided by U. You can either follow the same 30 centimeter, 15 centimeter given in the question, or you can use the ruler to measure the distance of the image and object distance, and you write it. And don't forget, on the top is image, at the bottom is the object. If you change, then your answer will be wrong. Okay, so this is the same case, this is the same rule, same type is applicable for all the cases. In the next video, I will discuss or explain how to get the image, the location and the nature for other 4 cases. This is case 1, which is beyond 2F. The object is placed beyond 2F, right? Now second case will be, I will move the object. You see, I move the object closer to the lens like this, step by step. Now I will move closer and place the object at 2F. Then again I move closer and place the object between F and 2F. Then again I will move object, I place at F. Then again I will move the object and place in between F and optic center. So every time I move an object, there will be the change in the what, in the image location and the size, the nature. Okay, thank you.